Today, we're going to talk about pub/sub architecture, one of the most widely used communication architectures in the world today. First of all, how do we find information from the internet? When we use our laptops to perform a quick search, our devices act as clients. We send a request, and if everything checks out, the server holding our information provides it to us. This is known as a client-server communication, which can be either synchronous or asynchronous. In a traditional setup, clients typically communicate with one server at a time, sending a request and waiting for a response. But what if we need to send data to multiple entities simultaneously in real time? The key here is to decouple the two and add something in the middle that can handle the communication for them. This way, data can be sent and can be received at a convenient time. The sender doesn't need to wait for a response to send a request again. Here, we establish a full asynchronous communication. When you're someone like Uber handling more than 30 million trips a day worldwide, or Netflix streaming content to millions of users simultaneously, a traditional request-response model is not good enough. Every time a movie is released or a ride is requested, sending a separate request to each user is not feasible at their scale. This is where pub/sub architecture comes in. We can break this architecture mainly down to 4 parts: a publisher, a subscriber, a message, and a topic. A publisher is the entity producing data, similar to a stock exchange like Nasdaq or LSE, who produces stock prices, or someone like us requesting a ride on Uber. A subscriber is an entity who's interested in receiving this data, people like stockbrokers waiting to make their next big win, or an Uber driver waiting for their next ride. A message is one data block, details of stock prices at one point in time, or information of a ride like the destination or the pickup location. And finally, a topic is a category or a partition which organizes these messages depending on a certain characteristic. To get a better understanding of this in much more simpler terms, let's take the scenario of us booking a ride on Uber. Now, this might not be the actual process of Uber, it's definitely more optimized than this, but this is enough for you to get an idea. So, when we book a ride, first we fill in the destination, the pickup location, and the type of ride they need, like Uber X or Uber XL. Here, our app is the publisher. Then the ride data, which is the message, has to fall into its own partition or category, which is called a topic. So the topic for this scenario can be the type of ride, like Uber X or Uber XL. Then the drivers get a notification in their Uber app saying that there's a ride and these are the details. So the drivers become the subscribers. The best part is that subscribers can subscribe to only the topics that they need. In this case, drivers with Uber XL vehicles needs to subscribe to only the Uber XL topic. This way, they will only get those requests. Now let's understand a really nice tool used to do all of this, providing services to billions of people, used by huge companies like Netflix or Uber to develop their highly distributed systems. Apache Kafka, developed at LinkedIn, is a distributed streaming platform that uses the pub/sub architecture to handle massive amounts of data from many publishers and also send data to many subscribers. In Kafka, one server that supports this is called a message broker, which acts as the middleman. This is great because publishers can write data into Kafka at a higher speed and subscribers can read the data at a slower speed if they wanted to. It is also distributed and replicated in many compute nodes, so is highly fault tolerant and can receive, store, and deliver many messages. Our public cloud providers have tools of their own which we can utilize to handle large amounts of data. If we take Amazon, they have AWS Kinesis data streams, or also they have AWS managed streaming for Kafka. Managed basically means that AWS will handle all the provisioning, the scaling, maintenance, security, and monitoring, so you can focus more on using the service rather than managing it. Google pub/sub is a tool developed by Google, and Azure Event Hubs is Microsoft's take on this. So that's just a small overview into what publish-subscribe architecture is. It is really important, and it's what runs most of the services that we use on a daily basis. That's all for the video, and thank you for watching.